Okay, welcome to the Geotechnical Laboratories here at Dundalk Institute of Technology. Today we're going to be looking at the Proctor Compaction Test. And in the Proctor Compaction Test, our aim is to identify the moisture content at which our sample of soil reaches its maximum dry density. And the way we achieve that is by taking a series of samples of soil which we've weighed in advance. In this case, this sample weighs 3 kilograms. And we're going to add water to it to achieve a known moisture content. So I'm going to add 300 ml of water, which weighs 300 grams, and that's equivalent to a water content of 10%. Then we're going to compact it in the Proctor mold here. And this is the compaction collar attached for safety. And we need to compact it in 3 layers using our automatic compactor behind me. So let's have a look at how to do that. First of all, we need to add water to the sample. Mix it thoroughly. And there's our sample. Now all the water has been thoroughly mixed through it, made sure there's no dry spots. Our 10% water content has been achieved. Now we're going to transfer the sample into the Proctor mold and compact it. And the aim in the compaction is to compact it in 3 layers. So the first layer will be just about halfway up and it will compact down to about a third. So I'm just going to level it a bit there before we start. There. So it's a little bit over halfway. And what I'm going to do now is transfer the mold, which I've weighed in advance. I've weighed it without the collar. I'm going to transfer it into our automatic compactor and compact it with 27 blows for this layer. Okay, we've set our automatic compactor to apply 27 blows of our 2.5 kilogram rammer to our sample, which is already located in the Proctor mold on the pedestal. Let's just take a look at it at the bottom of the compactor. So here's our sample. It's secured with 2 securing plates so it won't move during the compaction effort. I'm now going to start the 27 blows of compaction. Right, we've completed the compaction in the automatic compactor, and as you can see, I've taken the collar off the sample, leveled it off. I've now got the maximum possible amount of material inside the mold. It's at its maximum possible density. Each layer, each 1/3, has been compacted with 27 blows of our 2.5 kilogram rammer in the compactor, and this is as dense as it's going to get. I'm now weighing it, and I'm getting a weight here of 6.5 kilograms. And what we're going to do now is use that to work out the bulk density and dry density for this sample. We will repeat that 3 more times with 3 samples of different moisture contents. And by graphing the water content against the dry density, we'll be able to determine the best moisture content to determine the maximum possible dry density. So in the following tutorial, we're going to go through a set of test results from this type of material and calculate the maximum dry density. Okay, let's take a look at the calculations from the test we've just carried out. First of all, let's take a look at the water content. W. In our case, we had 3 kilograms or 3,000 grams of soil, and we had 300 grams or 300 millilitres of water. The water content is the mass of the water divided by the mass of the dry soil and then expressed as a percentage. So W is equal to, in our example, 300 grams or millilitres of water divided by 3,000 grams of soil times 100, and you can see that that will give you 10% water content in this particular example. So the moisture content or water content of our sample is 10%. Well, what about the density? Let's have a look at it. Density is always equal to mass divided by volume. In our case, I'm looking at the bulk density here, the mass is the mass of the mould with the soil in it minus the weight of the mould. And from the readings we took earlier, that is 6.5 kilograms or 6,500 grams minus 4,333. And the standard Proctor mould is 1,000 cubic centimetres. Let's work that out. 6,500 minus 4,333. That gives us 2,167. Divide that by 1,000 and you get 2.167. Now, that's in grams per cubic centimetre. However, that's the same units as megagrams per metre cubed, which are the units we would normally use to express the density of soil. The final thing we need to calculate is what is the equivalent dry density, the mass of dry soil material divided by the volume of the mould. And we can calculate our dry density, which is rho with a t beside it, is equal to the bulk density over 1 plus the water content. So in our case here, that is 2.167 divided by 1 plus our water content is 10%, which is 0.1 expressed as a decimal. If we divide our 2.167, 1 plus 0.1 is 1.1. That gives us a dry density of 1.97 megagrams per metre cubed. And that's how we calculate for one sample, the water content, the dry density, which is the maximum dry density we can achieve at that water content. The other 3 tests, or 4 samples, depending how many we do, will get different water contents, and we'll use those to draw a standard Proctor graph in the tutorial that follows.